right, we're starting a new unit, Systems of Linear Equations. So first what we're going to do is we're going to solve systems by graphing. So just some background knowledge, a system of linear equations is two or more linear equations. Now remember, linear, you can write it as y equals mx plus b. So as a quick refresher, b is your y-intercept, that's where you're going to begin on the graph. M is your slope, that's how much you move on the graph. And then x and y are any ordered pair that's on the line. So whenever you're graphing things, you want to put them into y equals mx plus b. So we're going to talk about the solution of a system, which is an ordered pair that satisfies both equations. So in order for it to be a solution, it has to work in all the equations. So just looking at this graph, it took these two equations here and it graphed them. And as you can see, they both intersect at this point. So this point, it looks like they're the same at -2, 3. So we just want to check to see if this is a potential solution. So we're going to look and we're going to substitute in our ordered pair into x and y. So I'm going to take 2, substitute it into x, or sorry, -2, and substitute it into x. I'm going to take 3, substitute it in for y, and then you're going to go ahead and simplify, and I'm going to get -4 plus 9 equals 5. Well, since 5 equals 5, that's good. So far this works, but it has to work for both. So now we're going to take x and we're going to plug it in or substitute it in here for -2, and then we're going to take our y and substitute it in for y, and then we're going to see, does it equal -17? Well, -2, and then remember it's -5 times 3, which is -15. Combine the two together, you get -17. So since it works for both, this is a solution. Now, one of the things with graphing, it's great if you have numbers where it hits at an exact point. However, it's not always accurate because either you can be off on your graph or your answers are not integers. So graphing is good if you need to see if you're in the right area, if you want to estimate, but really graphing should be the last resort unless you absolutely have to graph it, or it tells you to graph it. So what we're going to work on is deciding if a solution works by plugging it into the equation. So we have our system right here, and we're going to decide if this is a solution. So we're going to take our x, and let's zoom in here. We're going to take our x, and whenever you see x, you're going to substitute it in, and then we're going to take our y and substitute it in here. And then if we get true statements, it's a solution for both. So let's see. Remember, it has to work for both. Okay, so what I did here, just like I said, is I took 3, I substituted it in. Now notice this negative is outside, so that's why we had the parentheses here. I'm taking 1, substituting in here. That was a horrible circle. And now I've got -3 plus 1. And does -3 plus 1 equal -2? Well, yes, it does. So far, so good. But now we need to check this equation. So it works for this one. Now we need to check, does it work for this one? So let's look. All right, so again, we're substituting in x and y. And I'm going to get 6 plus 1 equals 10. Well, does 7 equal 10? No, it does not. So since it does not work for this one, it is not a solution. It must work for both. So even though it worked here, since it didn't work here, it's not a solution. So now let's come over here. We're going to check for 2 to see if this is a solution. So we're taking our same equations. Now I'm going to take my first equation, bring it over here, and I've got -4 plus 2, and then we're going to go ahead and simplify to get -4. We're going to bring this down, And negative 4 plus 2 equals negative 2. Well, does that equal negative 2? Yes, it does. So far so good, but remember it has to work for both. So we're going to do the same thing, substitute in your x. We're going to substitute in your y. Get 8, bring the 2, and then you got 10 equals 10. So since this works for both, it is a solution. So remember, it must work for both or for all the equations. All right, so now we're going to practice graphing. So this is just a review, and we're just adding another line to what we've already done. So first we're going to graph each line with y equals mx plus b. And so I'm going to come back here, and I'm going to copy, and then we're going to paste it right here just so it's right where we need it to be. Look at that, isn't that adorable? So cute. Okay, so anyways, here's our little reminder. All right, so we're going to figure out where they overlap or where they intersect, and they can have 3 different types of solutions. So first, we're going to start with this equation. So remember, your y-intercept is where we begin. So I did this in blue. So this is beginning on negative 1. And then from here, we're going to move. So we're looking at our slope of 3. And remember, when you have a slope of 3, it's really 3 over 1. So you're going to go up 3 to the right 1. So I'm going 1, 2, 3, right 1, plot a point. And then continue the pattern until you reach the end of the graph. And then I usually go the other way just to make sure I have all the points on there. All right, so this one, we're good. Now let's look at this equation. I did this in pink. So again, we're going to start at positive 4, and our slope is negative 2. So for negative 2, remember it's negative 2 over 1, you're going down 2 to the right 1. So from here, you're going down 2 to the right 1, down 2 to the right 1, and continue the pattern. Now if you notice, our lines already intersected right here at this point. So this point right here is your solution. And what we do is we write the solution as 1, 2. We write it as an ordered pair because at this point, your x and your y's are the same for both equations. So this is your solution. All right, so now what we're going to do is we're going to look at number 2. So I want to kind of zoom in a little bit. I'm going to move this over here. All right. So now number 2, this is in y equals mx plus b. So we're good, pretty easy to graph. Start at positive 2, and then we're going to go up 3 and over 4. Plot. Then you're going to continue up 3 over 4, and then I like to reverse it and go down 3, 4, and continue. All right. So now we need to put this into y equals mx plus b. So remember, we want to get y by itself. So we have to add 3/4 x to both sides. And then that cancels out because we moved it to the other side. And I've got y equals 3/4 x minus 4. So now we're going to start at negative 4, and we're going to go up 3 and to the right 4. Plot your point and continue your pattern. And I go reverse it, down 3 to the left 4. And if you notice, it does not intersect at all. So it's no intersection, and whenever there's no intersection, we say that is no solution. So it's parallel lines are always going to be no solution because they will never, ever, ever intersect. All right, so now let's look here, and we have, oh, okay, we got an equation here, an equation here. They're just kind of off-centered. All right, so first we need to put this into y equals mx plus b. So we need to get the y by itself. So I'm going to, over here, so I'm going to move this x to the other side by subtracting 3x. And then I've got negative 6y equals negative 3x plus 12. and then I'm going to divide each term by -6 because I want to keep the y here, but I got to move this over. So that simplifies to 1, so now we're left with y. This simplifies to 1/2, and this simplifies to -2. Now we can start at -2, and we can go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, continue the pattern, and then I like to reverse it down and to the left. All right, so far so good. So now let's look at the pink, which is right here. So for the pink, let me put a little, oops, that is not pink, hello. There we go. All right, so for the pink line, what we're going to do is I've already gotten it into y equals mx plus b because we want to get y by itself. So we're going to move 2x to this side. And I've got -4y equals -2x plus 8. So again, we want to get y by itself, so we have to divide each term by -4. Now that simplifies to 1y. This simplifies to +1/2, and this simplifies to -2. So if I were to graph, I've got -2. Oh wait, that's right where this one is. Okay, well let me go up 1 to the right 2. Oh, up 1 to the right 2, up 1 to the right 2, and then let me go down and 2, down 1 to the left 2. Well, if you notice, I'm actually graphing right over the same exact line. So when that happens, what that means is they're always intersecting. So if it's always intersecting, it's going to be infinitely many solutions, or IMS. So if it's the same line, so if it's the same line or equation, it's infinitely many solutions. All right, so what I want you to do is I want you to go through and I want you to try these. So you're going to plot them just how I did here, and you're going to determine, is it one solution? So this right here is one solution. And that's where it intersects, or is it no solution, or is it infinitely many solutions? Now, you can also solve the system by graphing them on a graphing calculator or on Desmos. We'll do that a little bit, we'll do that more later, but I just want to make sure that we are good graphing by hand first. And then I will say when you're doing these, you do have a couple tricky equations here. Your hint is HOI, horizontal line, zero slope, y equals. So think of which way you're going to move for that one. And then here, it's x equals, so it's a vertical line, undefined slope, x equals a number. So go ahead, graph those lines, and then, oops. Yep. All right, sorry. Okay, there we go. Yep, I had the wrong one there. All right, and what we're going to do is we're going to go through and we're going to do some inequalities with this. So for inequalities, we're going to do the same thing where you're going to graph each line, but if it is a less than or a greater than, it's going to be dotted. If there's a line underneath it, meaning less than or equal to or greater than or equal to, it's going to be a solid line. Now we're going to bring back what we did a while ago, and now we're going to shade. So depending on which way the signs go, you're going to shade either below the line, or you're going to shade above the line. Now truthfully, what I like to do is I like to pick a test point that's not on the line, and then I just shade that direction. So I already graphed this one here, and if you notice, it's a dashed line. And I graphed this one here. Again, it's a dashed line. So I'm going to pick a point that is not on the line, so or on either line. So I'm going to pick 0, 0. So if it's true, I'm going to shade the side with a point. If it's false, I'm going the other direction. So if you look here, if I were to have for here, this one. I plugged in 0 here. So I got 0 is greater than 0 plus 1. Well, that's false. So what I'm going to do then is I'm going to shade the other way because it does not contain this point. So I'm going to go right here and I'm shading all of that. All right, trying my best. It doesn't have to be absolutely perfect. And then I know that because I did my test point, but also if you look at your symbol, didn't we say you're going to shade above? So either way works. And now I'm going to look at my second equation that I graphed, and I did a test point 0, 0 also. And when I did that, I got 0 is less than or equal to, oops, did I not make that solid? I didn't make this solid, that's my bad. All right, let me go through. My mistake. So, all right, there we go. All right, so now that's solid. So now we're going to go through and we're going to shade. Since it's true, we're going to shade the side that includes it. So the point. So we're going to go here. And the shaded area where they both overlap, that is your solution. It's right in this area where it's purple. All right, so like I said, you can do the test point. You can think about what they're saying up here with what they're saying right here, where you shade below or you shade above, depending on the symbol. And then the solution is wherever it overlaps. All right, now on this one, I showed you how to convert both, and I did the blue, and that is dashed. And then I converted this equation to this, and again, that is dashed. So right now they don't intersect because they're parallel lines, but we want to know the shading for the inequalities. So we're going to do a test point. So for my blue, I did my test point of 0, 0. So it says that it's true, that 0 is less than 5. So since it's true, I'm going to shade that direction with that point. Kind of sloppy coloring there, but you get the idea. And then now I'm going to go through and I'm going to look at pink section, and I'm going to do a test point for the pink, which we said was 0, 0. And in this case, it said 0 is greater than 6. Well, that's false. So I'm going to do the other direction. So I'm not going to do the one in it. I'm going to do right here. And then again, wherever they overlap is the solution. All right. So what I want you to do is I want you to try this one. And I did number 4 for you, or I graphed it, and you're going to look at the shading. So I took each one, I converted them, and then it is a solid line. And then I took this one, I converted it, and it is also a solid line. And then now I'm going to do a test point. I can't do 0, 0, so I have to do a test point of -1, 1. So let's see what direction we can shade. So when I did 1, -1, then I got true, so I'm going to shade that direction. Okay, and then now let's look at pink. And for pink, I took my X and my Y, and I plugged them into the original equation. And so now I also got false So I'm not shading this direction, I'm going to shade this direction. So in this case, you're going to have an open area in the middle, so there's really no solution because it doesn't overlap. All right. So that, like I said, I want you to try this one and shade it. And then that is inequality systems and solving systems by graphing.